Imagine a world where the Earth stood motionless at the center of everything, where invisible forces governed the heavens, and where ancient texts held more authority than your own eyes. This was Europe before 1500, a continent where knowledge came from dusty manuscripts rather than careful observation. But between 1500 and 1700, something extraordinary happened that would forever change how humanity understood the universe. This transformation, known as the scientific revolution, began quietly in Europe before spreading across the entire world, bringing with it a radical new approach to discovering truth. For over 1,000 years, European thinkers had relied almost entirely on the wisdom of three ancient authorities. Aristotle, the Greek philosopher who lived in the 4th century before the Common Era, had shaped ideas about physics and the natural world. Claudius Ptolemy, working in the 2nd century of the Common Era, had convinced everyone that Earth sat fixed at the universe's center, while the sun and planets danced around it. And Galen, the Roman physician from the 2nd century, had defined medical knowledge for generations. These three men cast such long shadows that few dared question their teachings, even when observations suggested they might be wrong. The revolution began not with a sudden upheaval, but with a gradual questioning of old certainties. Through the 16th and 17th centuries, curious minds across Europe started to wonder whether ancient texts truly captured all of reality. What if the answers to nature's mysteries could be found not in libraries but in laboratories? What if human senses, enhanced by clever instruments, could reveal truths invisible to previous generations? This shift in thinking moved humanity away from simply accepting traditional wisdom toward actively testing and measuring the world itself. Enter Francis Bacon, an English statesman and philosopher who lived from 1561 to 1626, who dared to challenge the established order. Bacon argued that verbal arguments and theoretical debates had become more important than what could actually be observed in nature. He called for something revolutionary, a systematic approach where experiments would be conducted carefully, their results recorded precisely, and findings shared openly so other thinkers could review and verify them. Rather than asking why things happened before understanding what was happening, Bacon insisted scientists should observe, measure, and test. His vision was bold. Use this new approach not just to satisfy curiosity, but to improve the human condition in practical ways. What emerged from Bacon's ideas and the work of countless experimenters became known as the scientific method, though they might have called it experimental philosophy. This approach involved conducting practical experiments without prejudging what they should prove, using logic to form a hypothesis or untested theory, then designing experiments to test it. Results needed to be observable and measurable. Experiments had to be repeated in different places by different people to confirm reliability, and findings would be openly reviewed by other scientists who could critique and verify them. Mathematics became the language for expressing universal laws, and everything aimed toward practical benefits and the exciting idea of scientific progress. The scientific method needed tools, and the early 17th century delivered them in spectacular fashion. Around 1608, Dutch craftsmen created the telescope, allowing human eyes to peer deeper into the heavens than ever imagined. By 1610, the microscope emerged, revealing an invisible world of the infinitesimally small. 1643 brought the barometer for measuring air pressure, followed around 1650 by thermometers that could precisely gauge temperature. In 1657 came the pendulum clock, revolutionizing timekeeping with unprecedented accuracy. An air pump arrived in 1659, and by 1675, watches using balance springs made portable timekeeping possible. Each invention opened new doors of discovery. Among those who seized these new tools was an Italian named Galileo Galilei, born in 1564. Galileo crafted the most powerful telescope of his era, and when he pointed it skyward, the heavens revealed their secrets. The moon's surface, long thought to be made of some perfect celestial substance, showed mountains and valleys just like Earth. He discovered 4 moons orbiting Jupiter, watched Venus go through phases like our moon, and observed dark spots moving across the sun's face, suggesting it rotated. These observations challenged everything people believed about the cosmos and set Galileo on a collision course with religious authorities. Galileo's contemporary, the German astronomer Johannes Kepler, who lived from 1571 to 1630, made his own crucial contributions. Kepler designed an improved telescope using 2 convex lenses, and through patient observation, he confirmed the revolutionary model proposed by Nicolaus Copernicus, who had died in 1543. Copernicus had dared suggest that Earth and the other planets actually orbited the Sun, not the other way around. Kepler went further, demonstrating that planetary orbits weren't perfect circles as everyone assumed, but ellipses. After nearly 2,000 years, Ptolemy's geocentric model finally crumbled under the weight of evidence. The astronomical discoveries kept coming as more observers turned telescopes skyward. The Italian giant Domenico Cassini, who lived from 1625 to 1712, identified gaps in Saturn's magnificent rings. Johannes Hevelius, working in the Baltic port of Danzig from 1611 to 1687, discovered variable stars that changed in brightness and created detailed maps of the lunar surface. The Englishman Edmund Halley traveled to the remote South Atlantic island of St. Helena in 1677 to chart southern stars never visible from Europe. Halley discovered that the moon's orbit was gradually accelerating, noticed how stars moved relative to each other, and realized that certain comets followed predictable paths through our solar system. Perhaps no single figure embodied the scientific revolution more than Isaac Newton, the English genius who lived from 1642 to 1727. Newton invented a new type of telescope in 1668 that used curved mirrors instead of lenses, making larger and more powerful instruments possible. He discovered that white light wasn't pure, but actually contained a rainbow spectrum of colors. Most famously, Newton formulated his universal theory of gravity, explaining why apples fell from trees and why planets swept through their orbits. His mathematical laws could predict the behavior of objects from falling stones to distant moons, unifying earthly and celestial physics in ways never before imagined. While telescopes explored the vast cosmos, microscopes revealed equally wondrous realms in the opposite direction. A Dutch spectacle maker named Hans Lippershey, living around 1570 to 1619, is credited with the microscope's invention. The Italian Marcello Malpighi used this device to discover tiny blood vessels, called capillaries, in 1661. Finally explaining how blood flowed from arteries to veins, confirming William Harvey's theory of circulation. Suddenly, the human body's inner workings, which Galen had described so inadequately, could be seen and understood with unprecedented clarity. The English experimentalist Robert Hooke, who lived from 1635 to 1703, pushed microscopy to new heights. His book Micrographia, published in 1665, contained stunning illustrations that revealed a hidden world of intricate beauty. Readers gasped at detailed drawings of insect eyes composed of hundreds of tiny lenses, the delicate structure of feathers, and the porous nature of cork, which led Hooke to coin the term cell for the small compartments he observed. Meanwhile, the Dutchman Antony van Leeuwenhoek, born in 1632 and living until 1723, pioneered an even more powerful microscope design using tiny glass beads as lenses, discovering bacteria, protozoa, red blood cells, and sperm cells swimming in seminal fluid. Other instruments expanded scientific understanding in different directions. The Italian Evangelista Torricelli, who lived from 1608 to 1647, invented the barometer in 1643, enabling measurement of atmospheric pressure for the first time. The Frenchman Blaise Pascal demonstrated that air pressure decreased with altitude by carrying a barometer up a mountain. The German Otto von Guericke noticed that barometric pressure changed with weather patterns. The Englishman Robert Boyle, working with his assistant Robert Hooke, built air pumps that could create partial vacuums, allowing them to experiment with air pressure and formulate what became known as Boyle's law, showing that gas pressure and volume were inversely related when temperature remained constant. Around 1650, craftsmen in Florence created the first practical liquid thermometer, transforming medicine and experimental science. Doctors could now measure a patient's fever with precision instead of relying on vague terms like hot or cold or normal. Scientists could conduct experiments knowing exactly what temperature they were working at, making results reproducible and comparable. Then in 1657, the Dutch scientist Christiaan Huygens, who lived from 1629 to 1695, invented the pendulum clock, which used the regular swing of a pendulum to control a falling weight with extraordinary precision. These clocks lost only 15 seconds per day compared to 15 minutes for older mechanical clocks, and by 1675, watches using balance springs made accurate portable timekeeping possible for the first time. The scientific revolution wasn't just about individual genius working in isolation. It required new institutions where scientists could collaborate, share findings, and receive funding. Universities at this time focused on teaching, not research, so entirely new organizations emerged. The Accademia del Cimento opened in Florence in 1657, becoming the first true scientific society. The Royal Society formed in London in 1663, followed by the Royal Academy of Sciences in Paris in 1667. These institutions deliberately followed Francis Bacon's principles: conduct experiments systematically, share results openly, and submit everything to peer review. The Berlin Academy followed in 1700, and the St. Petersburg Academy in 1724. These scientific societies fostered unprecedented international cooperation. Scientists from different countries became fellows of foreign academies, attended each other's demonstrations, and maintained active correspondence networks. They worked to standardize instruments and measurements across borders. The German Daniel Gabriel Fahrenheit, who lived from 1686 to 1736, created his temperature scale around 1714. Sweden's Anders Celsius, born 1701 and dying in 1744, proposed an alternative scale. Having two standardized options was vastly better than every scientist using their own scale. Through colonial empires, especially those of the Dutch, French, and British, these revolutionary ideas spread far beyond European shores to every inhabited continent. Not everyone welcomed these revolutionary changes. Some intellectuals questioned whether the new instruments could be trusted, arguing that human senses might be deceived while pure reason could not. The French philosopher René Descartes, who lived from 1596 to 1650, remained skeptical about relying too heavily on experiments. Such debates actually proved valuable, creating a clear distinction between theoretical philosophy and what we now call science. Religious authorities posed more serious challenges. When Galileo supported the heliocentric model that placed the sun rather than Earth at the center of the solar system, church officials accused him of heresy, putting him on trial and forcing him to recant under threat of imprisonment. Yet most scientists during this period were devout Christians who saw no contradiction between their faith and their work. Many argued that microscopes and telescopes revealed God's creation in ever greater detail, increasing rather than diminishing their wonder at divine handiwork. Isaac Newton himself, despite explaining gravity mathematically, readily admitted he couldn't explain where gravity came from or why it existed, leaving room for divine mystery. Scientists wanted to understand how the world worked, not challenge Scripture. The boundaries of human knowledge remained frustratingly limited. Doctors understood disease causes better but still lacked effective cures, and the longitude problem that plagued ocean navigation remained unsolved for decades. Technology still had far to go. The revolution transformed not just what people knew, but how they imagined the universe itself. Popular literature began exploring mind-bending concepts like infinite space, worlds within worlds where parasites had their own parasites endlessly downward, and the possibility of life on other planets. If Earth wasn't the center of everything, couldn't other suns have their own planets? Might humans someday travel to the moon? New instruments revealed scales of measurement that defied comprehension, from distances that would eventually require terms like light years to dimensions that would need nanometers. The human body as a measuring standard gave way to a cosmos both unimaginably vast and impossibly tiny. Most importantly, a new confidence emerged among scientists. Given time and proper methods, technology and science could provide all the answers humanity needed to live better, longer, and more happily. The practical applications inspired by scientific revolution discoveries soon sparked yet another transformation. Sophisticated gear mechanisms in clocks, pistons in air pumps, and the recognition of air pressures power all influenced engineers and inventors. These insights contributed to developing steam engines and eventually triggered the British Industrial Revolution that would begin in the 18th century. The scientific revolution had proven that careful observation and systematic experimentation could unlock nature's secrets and turn that knowledge into practical improvements in daily life. Science became not just a way of satisfying curiosity, but a tool for genuine progress and human advancement. Today, the legacy of the scientific revolution surrounds us in ways we rarely pause to consider. When we speak of theories, hypotheses, laws of nature, empirical evidence, and scientific facts, we use language that was coined or refined during those two transformative centuries. The idea that knowledge progresses over time, that careful experimentation reveals truth, and that results must be reviewed and verified by others. These concepts seem obvious now, but were revolutionary in the 1600s. Science had replaced philosophy as the primary method for understanding reality and acquiring new knowledge. The experimental method pioneered by Bacon and his successors established science in a position of authority it maintains to this day, fundamentally changing how humanity approaches truth itself. Enjoyed learning about the scientific revolution. Give this video a thumbs up and don't forget to subscribe to the channel for more fascinating journeys through history. Hit that notification bell so you never miss our next exploration. See you in the next video.